Hey everyone, I'm Aaron Neiderhiser, CEO and co-founder of Tuva Health and co-founder of the Tuva Project. And today I'm going to give you a talk about open source healthcare data transformation and explaining what the Tuva Project is, why we started it, how we started it, what it's used for. And so hopefully you'll walk away with a better understanding of how you can use it to solve some of your healthcare data analytics problems. At the core, the Tuva Project is an open source code and knowledge base. Really for transforming raw healthcare data into normalized, enriched, quality tested data that's useful for doing healthcare analytics. And today it's used by more than 100 organizations. We started the project, my co-founder Coco and I started the project at the beginning of 2022. So we've been at it for several years now, and it took a long time to build the project. We probably invested what we estimate kind of more than 50,000 hours developing the project at this point. So a lot has gone into the project over the last 5 or so years. But over that time, more and more healthcare organizations have started to adopt it to really be their data model for healthcare analytics. So I want to explain it kind of in detail how we got started down this path in the first place. We've been in healthcare analytics, my co-founder Coco and I, for like over 15 years, basically our entire career post-academia. And in that time, basically the challenge that we've been faced with at all the different organizations that we've worked, Medicaid agencies, for value-based care startups, for other analytics and data warehousing companies, is how do you build a scalable healthcare data platform? But what do we actually mean by healthcare data platform? What do these words actually mean? Well, at the simplest level, it's about how do you go from raw claims or clinical data. And when we say clinical data, we usually mean electronic health record data, data that's coming from NHIE, it could be FHIR APIs. How do we go from these types of data to analytics insights? That is like information that is useful for understanding how care is being delivered. Where is it? Is it high quality care? Is it low quality care? Is it cost effective? Where are high risk patients? How can we intervene to provide them better care? Those types of insights. And this is actually like really tricky to answer questions like this. Like what is our spend, for example, for patients with type 2 diabetes? What does our ED utilization look like? What is our readmission rate for patients with COPD? These are all examples of the types of questions we might be interested in. But the basic problem is there's nothing in raw healthcare data that says this is the readmission rate for COPD. And there's nothing in healthcare data that says what a readmission even is, or what an index admission is. If you're familiar with computing hospital readmissions, you need to first compute qualifying events, which are often called index admissions. There's not even anything that's in healthcare data that says this was actually an acute inpatient visit. Instead, healthcare data, in this case, this is claims data, is made up of all these kind of like esoteric granular fields and code sets that are used for billing. And so it's things like bill type code or revenue center code, admit type code, admit source code, discharge disposition code, DRG. And really the challenge here is like, how do you transform this data, which is extremely like esoteric and not doesn't have the concepts in it that you need to ask analytically interesting questions? How do you transform this into data that is ready to answer those questions? And so the solution to this problem, going from raw data to analytically useful data, is to define analytically meaningful concepts on top of the data. And we don't just need, as you're probably getting a sense of here, we don't just need like a couple of concepts, right? There's actually a whole universe of concepts that we need to build on top of this data. And so that was really kind of the inspiration for starting the Tuva Project. There's actually one other problem that is related to this concept problem, which is we need to make our questions fairly precise, because these questions, for example, like what is the spend for type 2 diabetes? What does our ED utilization look like? What is our readmission rate? These are actually not very precise questions. So just to take the first example, what is our spend for type 2 diabetes? Do we mean medical spend? Do we mean pharmacy spend? Do we mean all spend? How do you even define type 2 diabetes, right? There's multiple ways to define almost any concept. How do you define if someone has type 2 diabetes? And then back to the spend, is it like all spend for patients with type 2 diabetes, or do we only care about the diabetes related spend? So we have to we basically have, to sum up here, we kind of have two problems that we have to deal with. One is raw healthcare data is in fact raw. It has all these atomic level codes that don't directly have the concepts that we need to answer questions. And then the second problem is we need to make our questions more precise. And the solution to both these problems is actually one and the same. It's we define higher level concepts on top of the raw data. And we define concepts that make the data usable for answering the questions that we're interested in. Like we define a concept for an ED encounter, or we use the word encounter and visit interchangeably. So like an emergency department visit, we define concepts for patients with type 2 diabetes, along with all other sorts of diseases and procedures and things like that. And then we define concepts that make our thinking and therefore our questions more precise. So what do we mean by total spend for condition X, for example? So that's really at the core of what the Tuva project is about, is defining this universe of concepts. Now, there's a couple of challenges in doing this. We need a lot of concepts is one of the challenge. And by lots, I mean like thousands of concepts. You can imagine how many different diseases are there, how many different procedures are there, how many different diagnostic tests, care settings. There's just a lot of things happening in healthcare. And when you think about kind of modeling all the different kind of activities and settings and so forth, that could be, there's a lot of concepts that we need to create. Another challenge is we need to define these concepts precisely in code. And so it's not sufficient to define them in English language, because English, even if you're very specific with your English, it's not mathematical, it's non-deterministic, it can be interpretive in a subjective way. And so we need to make the concepts defined as code, not just so that we can compute them, but so that it is like exactly clear how we're defining these things. And one of the challenges that used to exist when we first started doing this work is the people who are writing the code needed to have all this nuanced knowledge of healthcare data in order to do that. But the people that had that knowledge were often different people, like clinicians or somebody like that. And so when we first, before ChatGPT in November of 2022, and even more recently, kind of even into like the beginning, I'd say, of 2025, AI was not sufficient at solving this problem. But I would say now AI is really sufficient in kind of speeding up solving this challenge. Where today, when we are developing the Tuva project, we'll leverage AI, to not just write the code, but also to help come up with concept definitions. But that's still just kind of a sidebar on this. That still doesn't, you can't just trust AI to define all of these concepts, because AI is non-deterministic. And we need to, in order to have trust in how the concepts are defined, we have to do it in an open source way that's reviewable by everybody. So as a community, we can have confidence in how things are defined. I'll say a little bit more about that toward the end of the talk. So that challenge of building these concepts has been massively sped up. But like, let's unpack this like concept development challenge in a little bit more detail. So what happens when when an organization uses Tuva is they typically have multiple healthcare data sources. They'll typically have multiple payer claims data feeds. They'll typically have multiple clinical feeds. They'll have an EHR that has a backend database. They'll have maybe FHIR feeds coming in. They'll have from APIs. They'll have an HIE feed coming in. And the problem with at the most basic level is all these data sources come in different formats. So every payer, every health plan basically maintains their own special data model where they store all their claims data. And basically every claims data set you ever work with is going to have a slightly different schema. And every EHR data set, every EHR maintains its own distinct backend database. And all these backend databases have different schemas. And even FHIR, when you think of FHIR, you think, oh, that's standard. Well, it's not. It turns out it's every FHIR schema ends up being kind of a slightly different implementation of FHIR. And so all these raw data sources are actually in completely different formats, different data models, different field names, and different grains. And data quality problems are a given in healthcare data. And so they all have different challenges when it comes to data quality as well. And so if you're going to do analytics, you really need to unify all these different sources into a common model so that you can program against one schema when it comes to further developing analytics. And even if you do that, though, even if you do normalize all the different sources into a common data model with a common schema, common field names, common grains, that is still just raw data. We don't have any of these higher level concepts. So this is where we need to develop the whole universe of concepts. But the way we start doing that is we start developing that universe of concepts. The one thing the common data model does accomplish is when we start building these higher level concepts as code, that code only needs to be written to run against the common data model. It doesn't need to account for all the variation of all the multiple data sources in their different formats. And so that does solve a significant challenge. So getting to the common data model is really the first step. And then we can start to program and run these higher level concepts automatically once they're already developed. So with the Tuva project, again, we've developed a universe of these concepts. One of the most important ones is a service category grouper. So this is very important for claims data. You'll often have questions. Claims data is inherently it's information about the services that were rendered to patients, and these services have been by physicians in some care setting, right? And these services and the reason for the service was delivered was rendered as well, like what disease does the patient have, or what was behind this particular service. But there's claims data is made up of hundreds of thousands of different codes, right? And so to do analytics, we often want to know, hey, what service was this claim related to? And what care setting was it related to? Was this an imaging service, a lab service, an office visit? Was this a specialty visit of some kind? What care setting did it happen in? Was it acute inpatient, skilled nursing, outpatient? And so you need this sort of service category grouper to assign every claim to a mutually exclusive exhaustive hierarchy. Another example is the encounter grouper, right? So most encounters, or we use the word encounter as a synonym for visit, so a distinct healthcare visit. Many healthcare visits, healthcare encounters are made up of multiple claims. And if you want to understand the total cost of the visit or the total cost of the encounter, you have to group claims together. And this is a complex algorithm that you need to say, hey, this was an acute inpatient visit, this was an ED visit, this was a skilled nursing visit, whatever the visit level concept is. And then further, you need to be able to group. In healthcare, we often talk about episodes of care, which can span 90 days sometimes. Just depends on what the clinical episode is. Is it a knee replacement, a hip replacement, something else? And that is basically about grouping multiple encounters over a longer period of time together. And so these things are particularly needed and necessary for doing analytics on claims data. Then there's all sorts of fundamental concepts that are just important for analytics. So the concept of a patient and all their demographic information, the concept of conditions and procedures, of practitioners, locations, medications. These are kind of the core building blocks. And then there's sort of higher level concepts beyond that we think about that apply to both claims and clinical data. And we implement these as data marts in the Tuva project. And so it could be, defining a universe of chronic conditions, or defining a financial per member per month spend, or hospital readmissions, or ED classification for looking at what potentially preventable ED visits are, or CMS HCC risk models. And so these sorts of higher level marts are things that people are using as well. And really this is just a flavor of all the concepts that we have to build. But also, these are not anyone's secret sauce. And before we got started building the project, we had built these, basically an exact version of this at several different healthcare organizations. And so basically our reasoning for starting the project is everyone is reinventing the wheel on building this common data model, building all these higher level concepts. And really all this stuff should just be defined out in the open so that we can all have a conversation around, hey, what is the best way to define this service category, or the readmission rate, or whatever the case may be. And then we can move to, over time as an industry, we can move to, improve it and move to the best answer in terms of how the concept is defined. And then a follow-on effect is more and more organizations adopt Tuva is we all start modeling our data in the same way, and therefore we can start measuring healthcare in the same way. Because right now we're using all sorts of different definitions and we're getting all sorts of different answers, and everything is very inconsistent just in terms of how we do healthcare analytics as an industry. And so that's a little bit about what motivated us to start the project. The project itself is delivered as a DBT package. DBT is an open source project that basically just handles execution of SQL-based code inside of a data warehouse. So all of this all of this, this universe of concepts. This is just a bunch of data pipelines written in SQL that basically says, hey, take this table, transform it into this table, transform it into this table, transform it into this table, and you end up with this final set of output tables that is the Tuva data model that has all these concepts baked into it. And we use DBT to automate that. Basically, DBT figures out the right way to execute all of that code, and you can run. The code base is really thousands of different transformation steps. In DBT, just you can run it on your data with a single command, DBT build. And so these two things, the common data model and this universe of concepts, that's what makes up the final output to the data model. And all of this is designed, again, the other nice thing about DBT is it runs all this stuff in the modern data warehouse. Whether your data source is your claims data sets, your EHR data sets, whatever data warehouse you're storing those in, whether it's Snowflake or Databricks or BigQuery or Fabric or something else, DBT will do all of this data processing natively in there. So you don't have to move your data anywhere to take advantage of this. So that is kind of like the intro into the project and sort of how we got started. I want to actually show you a little bit of the project. And so again, all of this is completely open source. The best way to learn about the project and to start to interact with the project is just to go to the tuvaproject.com. This is our docs, our documentation site, but it also has our knowledge base where we have a ton of information about healthcare data and healthcare analytics. But let me just point out a few parts of the project. So again, you would be interested to use Tuva if you have kind of population scale healthcare data like claims, EHR, other clinical sources, and you need to do some sort of healthcare analytics like cost and utilization, clinical quality, something like that. If that is your situation, you are going to need some way to do all of this stuff in the middle. And that is what the Tuva Core platform is. The Tuva Core platform is the DBT package that lets you go from raw data sources all the way through, do data quality testing, normalization, claims pre-processing, the core data model, data marts, and ultimately get to this analytics ready healthcare data. So you can, we have a demo project that you can go check out in the getting started page. It ships with synthetic data. You can run it locally, either on your data warehouse that, whatever it is, Snowflake or whatever, or if you don't have access to a data warehouse and you still want to experiment, DuckDB is an awesome open source data warehouse that can run on your local computer that you can install in seconds. And so the demo works great with that. If you want to see kind of get a sense of hey, this sounds really good, but what types of analytics can I really do with Tuva once my data's in the Tuva data model? You can check out this dashboards page. We didn't spend a ton of time building these dashboards, but we just wanted to give people a sense of here's the types of analytics that you can do with your data once it's in the Tuva data model. And normally, if you were going to build if you're going to try and build these sorts of dashboards, this is a simple dashboard that stratifies cost by all the different encounter types, and you can look at spend and utilization. You can slice and dice by the condition to look at different populations of patients. If you're going to try and build just the dashboard like this on raw claims data, it would literally take you probably more than a year, because you wouldn't have the higher level concepts in place to be able to put this together. Building this dashboard on Tuva took us about 30 minutes. And so that just goes to we end up demoing a lot of these dashboards just to show people the types of things they can do with Tuva. But the point is, the visualization is actually the easy part. The hard part is the data transformation. Another thing that's really cool is the Tuva project helps maintain all sorts of different data assets that are necessary for healthcare analytics. So these are things like terminology code sets like ICD-10, SNOMED, HCPCS, reference data sets, value sets, like how do you define, basically lookup tables for all sorts of different data marts, provider data for, like NPI and provider specialty, and then our synthetic data. And we host all these data sets, again, open source, on DoltHub. DoltHub is just a version controlled MySQL database, essentially. It's like GitHub for databases. And you can go look at any of the data sets, any of the data assets. So this is like the terminology database, and you can go look at all the codes, and you can query them and search through them. Even larger code sets like ICD-10 CM. And you can just run basic SQL to try and look for specific codes. And you can also like do pull requests. So as the open source community maintains these, and Build Hub allows you to do a pull request to make an update just like you would with GitHub. There's a lot more to the project. I could probably talk for another hour just going through in detail all the different types of the project. But if you're interested, I would encourage you to go here and learn about it and check out the Getting Started page. The other thing I'd encourage you to do is join our Slack community. The Tuva Project Slack community is basically a group of more than 2,400 healthcare data and analytics professionals that are just we're building the Tuva project together. We're using it. There's lots of conversation around how it should be built, how to do healthcare analytics. And so I encourage you to come here and you can network with other people. People post jobs in the jobs channel. So if you're looking for a job, that's a good place to go. And then if you want to stay up to date on all this, we have a weekly newsletter, the Tuva Project newsletter, that we publish weekly, or try and be relatively consistent there, which is the latest stuff that's happening with the Tuva project or just with healthcare data and analytics in general. So that's kind of all I plan to share. I hope this was interesting. I hope you learned kind of a little bit about the Tuva project and how it might be useful in your work. If you want to get in contact with me, probably the easiest way to do that is you can send me an email at aaron@tuvahealth.com or join the Slack, and I'm just Aaron in the Tuva Slack. All right. Thank you.